Hi, folks, this is question 6. Uh, Quite simply, all we need to do to start off is a is equal to sin inverse of a half, and you can use calculator, and it gives you 30 degrees. If we go to our diagram to CAST, it tells us where everything is positive, and sin is positive because it's positive, it's in that quadrant there, so that's one answer, or it's 30. And then if we make a reference angle here as 30, and because it's sin is positive in that quadrant, then from there to there has to be 150. So therefore equals 30 and equals 150. There are two solutions, and you'll get a good few marks if you just get those. And because we can just go around a full circuit again, we just have to add 360 to both of those. So if we add 360 to 30, it gives us 390 degrees. And if we add 360 to 150, that gives us 510. And then important thing here is the bounds. They have to all be between minus 360 and 720. If I was to add on another 360 onto that one or that one, it would take me above the bounds. So we can subtract 360 from 30. So 30 take away 360 is minus 330. That's still within what we want. And if I were to do 150 take away 360, yeah, you get minus 210. So there's all 6 solutions then. Right, so this question, it's a trig graph, but there's modulus in it. So the two lines either side of the 4 sine x there are modulus. If you were to take the graph f of x equals sine x, it would look like something a bit like this. So it goes and down, up and down, and up and down. So they should all look symmetrical, but uh, because the modulus is in it, it gets rid of the bit underneath because you can't have anything as less than zero when it's modulus, because modulus makes everything positive. So it's like it just comes straight back up there instead. So that's basically your graph. To make it a bit more clear, something like that. Originally, the graph, if it went like that, that would be the period of the graph originally, and that would be 2 pi from there to there. So if you were to start at 0, so up and down and up, that would be 2 pi. But because this one is half that, the period is half, because it just goes down, it just goes up, down, and then that's it. It doesn't go down further. So, and then it repeats, it goes up, down again, and then it repeats, goes up, down again, repeats, goes up, down again. The period is just half of that. It's like there. So it kind of stops, it goes up, down, but then it's back to the start and it goes up again. So the period is half of 2 pi, and that's pi. And in the range, you'll notice it just goes down. It's not actually, my graph here isn't exactly the same as this graph. This one, it goes down just below the axis and then goes up, and that's because of the minus one in it. The minus one shifts everything down, so it goes down to minus one, and because of the 4 there, that means that the distance from there to there is 4. So if that is minus 1 there at that point, and then and then it goes up by 4, then it has to be 3 up there. Therefore, the range has to be minus 1, 3. So it's tricky enough there with the absolute value signs. It kind of throws everything out the window. I have to use cosine rule here. So I'll just write down cosine rule anyway. If we fill in, the 2 is the furthest thing away from the angle. So 3 squared plus 4 squared minus 2 times 3 times 4. Cos of the angle, we'll just call it B because it's at B. Bring over the 9 and the 16 to the other side, we'll get minus 21 is equal to minus 24. Cos B, bring over the minus 24 and divide it, we get 21 over 24 is equal to cos B. And it's nice and easy up to here. All you have to do is just use cosine rule, move things across. So it's an interesting kind of question. It doesn't really come up that often. So they want the value of tan of CBA instead. CBA, yeah. So if we know the cos of the angle, I'm just going to draw it in a right angle triangle and we'll just call that B. I know that's not the original triangle, but the ratios still work because we know cos of B is adjacent over hypotenuse, so 21 over 24, and we're looking for tan ultimately. So really we're trying to find out what the opposite is here, so we'll just call that Y for the minute. So use Pythagoras, so 24 squared is equal to Y squared plus 21 squared, therefore 24 squared minus 21 squared and square root is equal to Y, and that's 3 root 15 equals Y. For tan of the angle will be opposite, which is 3 root 15 over adjacent, which is 21. And you can simplify that down into root 15 over 7. Now I could have spot here, I could have changed uh, changed that into 7 over 8 either, and then moved gone with that into the triangle. So it'll be the same thing. I could have simplified that fraction there. So either way, it'll give you the same answer down at the end.